Hey everyone, today we're going over LeetCode problem 253, Meeting Rooms 2. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. This problem is very similar to Meeting Rooms 1, which is another problem I solved on my channel. In this problem, we are given an array, and this array is called intervals. And each interval in this array has a start time and an end time. What we want to do is basically return as an integer the minimum number of conference rooms needed for these meetings to occur. So basically we have an example here where we have an array of intervals and we have 3 meetings. And what we want to do is simply go and see what is the maximum number of meetings that occur at the same time. Because if we have, say, 3 meetings which conflict, then what we need is at least 3 minimum conference rooms in order to hold all of these meetings, because they all have to occur in different rooms because of the time conflict. However, if the meetings do not conflict based on time, then we can reuse the same meeting rooms, and we would not need to increase the number of conference rooms that we require. I've created a more complicated example here down below with 4 intervals. We see we have a first interval which starts at time 0 and ends at time 3, a second meeting starting at time 2 and ending at time 8, and a third meeting which starts at time 4, ends at time 6, while our last meeting starts at time 5 and ends at time 7. Now I think that in order to understand what algorithm we need to use in order to solve this problem, it's convenient to depict these intervals along a timeline. So we have these intervals along a timeline, and we want to see how many of these meetings conflict during a specific time interval. So we start off and we see that our first interval starts at time 0. This interval then ends at time 3. However, we see that at time 2, we have our second meeting which begins. So we can see that because meeting 1 ends after meeting 2 begins, there will be a portion in time where these 2 meetings occur at the same time. Therefore, during this period in time, we will need at least 2 rooms in order to hold the meetings in separate rooms, before which, instead, we would only need 1 room. Now, after this first interval ends, we know that we no longer need that additional room. So for the next period of time, we would only require 1 conference room. Afterwards, at time 3, we see that we have another meeting which starts. Therefore, we will have a period of time in which interval 2 conflicts with interval 3, because interval 2 has still not yet ended. So during that period of time, we will once again require 2 meeting rooms. When we continue on, we see that then at time 5, we have another meeting which begins. However, neither interval 2 nor meeting 3 have ended. So because of this, we will have a period of time in which we will need 3 meeting rooms. Then we see that this interval 3 ends at time 6, so we can go back down to needing only 2 intervals. And then at time 7, our last interval, interval 4, ends. So we can go back down to needing only 1 room until our last meeting, meeting 2, ends at time 8, after which we will no longer require any more meeting rooms. Basically, in this problem, what we need to return is the number 3. We will require 3 meeting rooms, max, in order to have all of these meetings occur, because some of these meetings conflict in time, so we need at least 3 separate rooms in order to hold all of the 3 meetings separately. Now, based on how we went through the timeline, we can see how we could actually solve this algorithm. What we could do is create an array which will keep all of our start times for the intervals, an array which will keep all of the end times for our intervals. So we have here an array for the start times, and what we will do is go and put all of the start times that we have in our problem. However, what we want to do is sort these start times in increasing order. For our end times, we know that we have a meeting which ends at time 3, then we have another meeting which ends at time 6, one that ends at time 7, and one that ends at time 8. Then basically for our algorithm, we're going to have 2 pointers starting at the beginning of each array. We could call S the one that's for the start times, and E the one that's for the end times. And we're going to see what occurs next. In this case, 0 comes before 3, so we know that we will have a meeting start. So a meeting is going to start, and we're going to need an additional room, so increase our current rooms to 1, and then we check to see if we have beat our current max rooms. We have in fact beat it, so we increased our max rooms to 1. After which, since we knew that a meeting started, we now have to move our start pointer. So we go and move our start pointer for the next iteration. Now again we see that at time 2, which is smaller than time 3, another meeting starts. So we need to increment our current rooms to 2. And once again check to see if we have beat our current max rooms. And we have, so we increased our max rooms to 2 as well. After which, once again, we move our start pointer. Our start pointer now points to a meeting which starts at time 4. However, before time 4, at time 3, we have a meeting which ends. So what we will do is again move our end pointer instead, and this time decrease the amount of current rooms that are going on. So we decrease the amount of current rooms from 2 to 1 because the meeting has ended, and we take our end pointer and move it to the next element in our array. Now we see 4 comes before 6, so we see that another meeting has started. So once again, we update our current rooms. We increase it by 1, and it has become 2 again. Once again, we move our start pointer for the next iteration, and we see that we're at a 5, so another meeting has begun. And for this reason, we increment our current rooms from 2 to 3, and we see that once again, we have reached a new max number of rooms, so we need to update our max rooms from 2 to 3. After which, we know that we last started a meeting, so we would need to move our start pointer. However, there are no more meetings that could start, so we know that from this point on, we would only have meetings which end, which means that our current number of rooms would only decrement from 3 to 2 to 1 and to 0. So at this point, when we're done with our start times, we could actually just end our algorithm and return what we have for max rooms, which in this case is 3. Our time complexity for this algorithm is O of n log n, and this is because of the sort we have done for both the start times and the end times. And given we have n intervals, it will take n log n for this sort to occur. After which, we're going through the start times and end times in linear fashion. However, our overall time complexity remains n log n. Before writing up our code, I wanted to mention that in addition to being n log n time, our algorithm is linear in space, and this is because of the start arrays and the end arrays that we're going to keep in order to store the sorted start times and the sorted end times. We're going to create our empty start times and end times arrays, and after which we're going to iterate through each and every interval in our intervals array. We can deconstruct the interval and separate it into start time and end time. And after which, we're going to add each and every start time to our start times array, and each and every end time to our end times array. After having created our initial arrays, now what we have to do is simply sort them. So we can say start times.sort and end times.sort. Furthermore, we need to initialize our start pointer, our end pointer, our current rooms variable, and our max rooms variable all to 0. Now we want to start our comparison of the start times against the end times in order to determine how many rooms we need. Now this comparison will go on until our start pointer does not reach the end of the start times array. Now, if the start pointer points to a time which comes before our end pointer, then what we need to do is increase the amount of rooms that we currently need, increase our start pointer by 1, and also update our max rooms if needed. In the other case where our end pointer points to a time which comes before, instead we need to decrement our current number of rooms by 1, but still increment our end pointer. And once we're done with this while loop, we're done with the comparison, so we can return our max rooms. Let's make sure this runs. And we see that it works. Thank you so much for watching this video. If you enjoyed it, please give it a like and subscribe to my channel. I'll see you on the next one.